Problem 1, we talk about the activation of the target. You know, in the case of activation of the target, uh, we have an incident particles bombard a stable target nuclei. In this case, we have Na23, and we have the incident particles neutron N01. Okay. After the bombardment, we create an unstable target nuclei will be Na24. So first of all, I ask you to find or to write the nuclear reaction. The nuclear reaction part 1 will be neutron 01 will bombard one atom of sodium Na23 to give sodium Na24. Okay, this is a nuclear reaction. I come back to the last videos. In general, we have incident particles will bombard a stable atom or a stable target nuclei to create an unstable nuclei. Okay, this unstable nuclei will decay after to a stable nuclei. Okay, we have two terms. We have artificial creation of unstable nuclei, and we have a natural decay of this unstable nuclei to a stable nuclei. So in general, the equation of the production of unstable nuclei delta N divided by delta T equals to the activity, the initial activity of the creation of the unstable nuclei will be A0 or NR minus the decay rate of this unstable nuclei lambda n. You know, we did the calculation before. I will repeat the same calculation now to find a general expression of lambda n, or we can say A equals to A0 1 minus exponential lambda t. I have to find this relation because in the second part, I tell you the production speed is 10 power 8 atoms per second. What I mean here, you have number of atom per second. Here, this is the activity. Okay, when I say the production activity, it means I am talking about NR. Okay, so here we have NR or A0 equals to 10 power 8 atoms. Which atoms here? Production of sodium 24. Okay, we have atoms per second. This is the production or the activity of production of unstable atom of sodium 24. Okay, now I ask you to find the maximum activity of sodium 24, the maximum activity. First of all, let me calculate this expression and we come back to the question. Okay, I have to solve part 2. We can start by delta n divided by delta t, which is equal to nr minus lambda n. And if you come back to the video before, you can see in details all the calculation to find the expression between the activity A and A0. So we can simplify this one by writing delta n divided by nr minus lambda n equals to delta t. Here we can multiply by lambda both sides, delta d lambda n times lambda delta t, and also we can change here, just we can put minus here and minus here. We can put minus, and we change this term. Okay, we get here minus nr plus lambda n. Just I multiply by minus to each side. So we can get delta lambda n divided by lambda n minus nr equals to minus lambda delta t. If you do the integration for each side, you know the limit. Initially, we have 0 unstable nuclei of sodium 24. We have 0, and at a time t, we have n number of target nuclei sodium Na24. So 0 and t. This one equals to ln lambda n minus nr between 0 and n, and here we have minus lambda t, okay, between 0 and t. This one equals to ln lambda n minus nr minus ln, if we put n equal to 0, minus nr equals to minus lambda t. Okay, so this one equals to ln lambda n minus nr divided by minus nr equals to minus lambda t. We can simplify this one by minus and minus, we get plus plus. Okay, so ln lambda n minus nr equals to lambda t. We can say lambda n minus nr equals to exponential lambda t. Okay, or here let me keep minus and minus. Okay, I don't change because I need to find exponential minus lambda t. So we have minus and minus, and here we get, excuse me, here we get lambda, okay, lambda n, we can say directly lambda n minus nr divided by minus n r equals to exponential minus lambda t. Okay, so lambda n minus n r equals to minus n r exponential minus lambda t. So lambda n, or n, we can say n, n equals to 1 divided by lambda. Here we can say n nr 1 minus exponential lambda t. Okay, this one, or you can say lambda n equals to nr 1 minus exponential lambda t. And you know lambda n is the activity at a time t, and nr is the activity initial a0, 1 minus exponential minus lambda t, minus lambda t, again minus lambda t. Okay, okay, here I come back to the question. I need to calculate the maximum activity. Look here, to get a maximum activity, this term must be equal to 0. Okay, to get A equals to A0. Here, because we have a negative sign, in order to have a maximum A, we have to eliminate the negative term. So to have a 0 exponential minus lambda t, we can say at t at infinity. If t goes to infinity, so we can say exponential 0, which is equal to 0. Okay, we can say exponential minus infinity, which is equal to 0. Okay, so we can say at this point A equals to A maximum equals to A0. You have to know we have a maximum activity at T infinity. We have the activity initial equals to activity at any point. A activity equals to A0 at T goes to infinity or tends to infinity. This is the condition. Look here. If I give you, for example, you have lambda, you know lambda equals to len 2 divided by half life t half. If you have lambda, I give you, as in this problem, A0, we can say here, and if you have A, you can calculate t, the time. Anyway, we can say here A equals to A maximum equals to 10 power 8 atoms per second, because A0 is the production of unstable atom sodium. Okay,